Hello, I'm Mr. Craig, and I want to work out a few of the stoichiometry review questions for the test. These are the types of questions that you're going to be expected to know how to work out. What you're not going to be comfortable with at first is recognizing that the format is not exactly the same as the format of the homework questions that I gave you over summer break. However, this is past AP exam questions. Also, it's based on what the National Math and Science Initiative wants us to do as AP teachers, and also what colleges want us to do and college professors want us to do. So you might notice that the wording or the phrasing is a little bit different. You may also notice that there are some aspects of chemistry that we haven't covered yet, but you have discussed in honors chemistry or pre-AP chemistry, more appropriate. So please don't be offended if you see something that you don't know how to do or that you don't remember how to do. This is a great opportunity for you to go back and review some of your honors chemistry material that may not have been covered or in the summer packet. Also, on the AP exam, you may see questions that you've never seen before, or topics that you've never seen before. That's okay. What you don't want to do is leave a question blank. The whole point of seeing questions phrased in the way that you see here is for you to learn problem-solving skills. And that's what I plan on doing with you all year, and Mrs. Blasky, if you have her as well. So we'll be giving you problem-solving skills to help you to solve these problems. So what you don't do is you don't read the question and then give up. So there's always a couple components to a question. You always read the question carefully. You always ask, what is the question giving me? The most important thing is read the question, and then make sure that you actually go in and answer the question. So let's take a look at these, and I'll break these questions down into the different years. Now, some of you are like, whoa, 1982. And I'll also be perfectly honest with you. The way that the questions are asked on the redesign of the AP exam is a little bit different, but again, this is still chemistry, and it's still problem-solving skills that you need to know how to do. So even though this type of question or this same exact question won't appear on the test, and I promise you it will not, but there are still skills and traits that you need to know how to do or to solve for. So you're building up your repertoire, so to speak, of your skills of chemistry. So let's take a look at 1982. Question asks, and the way that the format for all of these questions are, you'll see that all the questions are bunched up here. There's no space in between, because what College Board doesn't want you to do is have an idea of how much information you should put in there. So we always answer our questions past the actual question itself. So in some points or some parts of the question, it might be just you write a single number or a single word. And some things you may have to work out quite a bit of work, but we don't leave a question blank. All right, sorry about that rant there. 1982, water is added to 4.267 grams of UF6. The only products are 3.730 grams of a solid containing only uranium, oxygen, and fluorine, and 0.97 grams of a gas. The gas is 95% fluorine, and the remainder is hydrogen. Okay, so right there, that's all information. What I don't want you to do on a question is automatically go to A and start looking at how to answer the question. You have to realize what is given here. And by looking at this, you're saying that, okay, we have water in this. So based on the type of question or the topic, you know you have a stoichiometry problem. So let's go ahead and do step one. Now, the question may not ask you to do that, but it's probably not a bad idea to have that written out. So we have water, which you can write as H2O or HOH, which you'll learn later on in the year, a good way to write it. So water and uranium hexafluoride, so UF6. And what's it say? Water is added to so I'm going to write this down, 4.267 grams of hexafluoride. The only products are 3.730 grams of of a solid containing only uranium, oxygen, and fluorine. So we have a compound of uranium, fluorine, and oxygen. And we're probably going to go X, Y, and Z there. And that's not a 2, that's a Z. That's a Z there. Okay. Containing and we have 0.97 grams of a gas. And the gas is awesome enough. So some gas, let's just write gas. So we have a gas that's 95% fluorine and the remainder is hydrogen. Okay. So in this gas, we have fluorine gas and hydrogen gas. Now, what that doesn't mean is that we make up a compound, necessarily. We don't make up a compound. There could be two gases that are together here, and I'm assuming that we're not forming a new compound there. So it's fluorine gas and hydrogen gas. So that's what we have here. So this looks like a pretty interesting type problem here. So A, from these data, determine the empirical formula of the gas. Means the smallest whole number ratio. And in this case, we have a gas that is composed of, we'll say, fluorine. Actually, let's do it this way. Of fluorine and hydrogen. So what that means is, if it says that it's 90% fluorine, then I'm going to say I have 95 grams of it. So I'm going to change that 95% into 95 grams. And whenever we do empirical formulas, it's always what's on the periodic table. So we never see F2, H2, O2, N2, any of those on the periodic table as diatomic, even though that's the way they exist in nature. So we're going to leave it as that. Maybe we have a compound here. We just don't know yet. So we're going to change this into moles. So empirical formula is the smallest whole number ratio of moles. That's something that we can work with. And fluorine on your periodic table is 19.0 grams. Get a number for that. And then if you have, say, 95%, that means that hydrogen is, very good, 5%. So we'll change that into 5 grams. And that is of H. Should change that F. So 1 mole of H, F. So hydrogen's that. So let's get some numbers there. It gives me a value 5. And that's moles, 5 moles. And the hydrogen, we're going to say that's roughly 5 as well. I mean, yeah, it's going to be 4.99 something, but we'll say that's close enough to be 5. Now remember, whenever you do empirical formulas, you're not going to say, oh, I've got 5 moles of that and 5 moles of that. We're looking for the smallest number ratio. So be sure to divide each by the smallest number, which in this case is 5. So we have a 1-to-1 ratio here. So a 1-to-1 ratio, which means that for every H, or for every F, we have a 1 hydrogen. Here's the empirical formula for our gas. So it looks like we can correct this and say that it's not F2 and H2, but we do have a reaction, and that we formed HF. Or if you want to write it as FH. We'll talk about that later on. So part B says what fraction of fluorine of the original compound. So we want to know how much of this fluorine, what fraction of it is in the solid and what fraction is in the gas. Okay, so we're looking for a fraction of fluorine in solid and a fraction of the fluorine, oh, I can spell right, of fluorine in gas. Okay, all right. So what we need to do is, first of all, we have our total amount here of UF-S6, and then we have our, we don't know what our actual combination is here, but we don't care, to be honest, we don't care yet. Because once you find out what the fraction of this is, then that will determine what that fraction is. So let's first of all find out how much of the fluorine we actually have in our UFF6. So remember mole fractions? Mole fraction. And we did this in honors chemistry or pre-AP. You have the mass of your element, or the thing that you're looking at, over the mass of your entire thing, which in this case is UF6. Okay, so we can find out what that fractional amount is for this by doing, okay, so we know that we have 6 fluorines, so 6 times 19 divided by uranium, I believe it's 238. 238 plus, let's see, the 6 fluorines, so again, the 6 times 19, and let's get a value for that. That'll actually give us a nice little percentage too. And that gives 0.3, we'll say 3.8, my calculator has that. So that is, if I were to change that into a fraction, it's about 1/3. I'm going to leave it as a decimal here. But what I want to do is find out how much fluorine I have. And of this sample, the 4.267, this will tell me how much total fluorine I have that I started with in the compound. So I'll take that value. It gives me a value of 1.38, we'll say 1.38 grams of total fluorine. So this is our total amount of fluorine that's in the reaction. It's in the reaction. Okay? All right, so knowing that, and we also have an amount for our 0.97, we know that 95% of that is made up of fluorine. So let's do this. So we have, what was that value? 0.97. So 0.97 grams. And we could subtract that from the 1.38. Actually, let's move that on down. So 1.38. This is our total amount. And this is our mass that we have. Whoops, sorry. We need to multiply that by 95%, sorry. Times 0.95. So 0.97. 0.9215. Yeah. So really, what we have is, boom, that divided by that. Or sorry, subtracted from that. Okay, so we'll take this minus this. That'll give us our amount of fluorine that's in our solid right here. Okay, and then we can hopefully find out some information about that. So let's see here, 2.4585 grams. Okay, so that's in our, this is in our gas. This is in our product solid. Okay. Now that we have that information, I think we can answer the question. And the question's asking, what fraction of fluorine of the original compound is in the solid and what fraction is in the gas after the reaction? Okay. So we have our, here's our original amount and here's our product. So we can simply do this. So for the gas, let's do the solid, is equal to 0.4585 divided by the total, which is 1.38. And we can also do for the gas, which is 0.92 divided by the 1.38. Okay, I'm going to actually get some values there. So what I got here is that this is oops, sorry, the first one is a third. Actually, my value on the calculator says that it's 0.3322, and that is a percentage there. I know it's asking for a fraction, but it's odd that on College Board, sometimes when they ask for a fraction, they're really looking for a percent. Very odd, very odd. And then, in this case, 2/3, which is approximately the 0.66, we'll say 8% here. So, as odd as it seems, 1/3 of the actual fluorine is within the compound, and 2/3 is in HF. Okay. What is the formula of the solid product? Okay. So let's find out what the formula of the solid product is. Asking, what is the formula? So the empirical formula probably would be the best way to say that. So let's find out. Okay, so and analyze the problem. Now the question never asked us to write this problem out, but here's some problem-solving techniques. First thing, if I look at the balanced equation, and again, it's not very well balanced because we don't know what this is. But what I do know is that uranium only appears in this compound and uranium only appears in this compound. So what that means is all of the uranium that is in the uranium hexafluoride is contained in this compound here. So once I found out how much uranium I have here, that's going to make up all the uranium there. I now know how much fluorine is in this compound. Cool. Okay. Also, I knew somewhat how much oxygen I have because I can add these two up and take the difference of these two to tell me how much of the water I have. But we'll work that out. So let's go ahead and do the uranium and the fluorine first. Actually, the fluorine's already finished for us. So what we're trying to do is the empirical formula. So we know we have 0.4585 grams of fluorine in the solid. So 0.4585, yep, grams of fluorine. Okay, now let's find out how much uranium we had in there. So we know that we had 1.38 grams, I believe, of fluorine. Yeah, so I have 1.38 grams of fluorine. So I can subtract that fluorine from the uranium. So 4.267. I'm going to do a little sidebar. The uranium, 4.267. Minus. Notice how all these build upon each other. Pretty cool. So we have 2.887 grams of uranium. So I'll go ahead and say I have 2.887 grams of uranium. And uranium again comes in at a hefty 238. Okay. And then oxygen. We know we have the mass of our uranium and our fluorine in the compound, and we know that the overall mass of our whatever this is 3.730. So let's do that. Let's scoot that down a little bit. So our oxygen is going to be equal to, again, it was 3.73 minus the values that we just found, the 2.887 plus the 0.4585. Okay, and that will equal, and that equals 0.3845. So let's go ahead and go blue on that one. So we can go 0.3845. oxygen. 1 mole of oxygen, 16 grams. So let's get some values here. 0.024. Now I don't want to round this too much. And I know I may be writing quite a few, but I always like to write more than enough. Now, once you get into race mode, we'll clean this up and we'll keep the values in our calculator. But for now, for the sake of knowing how to work this out, it's probably a good idea to show as much information, because when we do our mole fraction, you want to make sure that it's as close as possible. And fluorine is 0.024132. Sounds pretty close. We would say these are very, very close to each other. But let's keep going and then do this for the uranium. 0.01213, which obviously is the smallest number of moles amongst them all. So what we want to do to find out what the empirical formula, or the formula for this, is divided by the smallest number ratio. I'm sorry, the smallest number of moles, which in this case is, actually let's go with this value. 0.1213, that's a 1. 0.1213. That's very, very close to 2. It's like 1 point, I'd say 1.0000 something, or I'm sorry, 2.000 something repeating. And then same thing here, 0.1213, which is 2. So our empirical formula for this is that we have 1 uranium, I think it's UFO. Yeah. So 1 uranium, 2 fluorines, 2 oxygens. Is our empirical formula. Let's see here. How did they list them? Oh, it did list it as oxygen, fluorine. Okay. Now, since this question listed it as uranium, oxygen, fluorine, let's keep it in that order. So I'm going to go ahead and adjust that. Oops. I'm going to move you over here just for a second. Actually, throw you away. We don't need that. So I'm going to rewrite this as UOF. Bring this back down. Okay. Since the order was listed as UFO, I'm sorry, UOF, let's go ahead and leave it at that. So the answer here really should be UOF. Okay. All right, doesn't change anything that we did there, but generally we want to write the formula in the order that the elements are listed, so we'll want to stay consistent with that. All right, letter D. Okay, write a balanced equation for the reaction between the uranium hexafluoride and the water, assuming that the empirical formula of the gas is the true formula. So we'll say that that is what it is. So now all we have to do is balance this. So we'll rewrite it now that we know what it is. So this is letter D. And I mean, you can do the inventory or you can just look at it. Here we have 6 fluorines, here we have 2, here we have another one which makes 3. If I only put a 2 in front of here, then that means I'm going to have to put at least a 2 here, which means I put a 2 there, which changes that to 12. So let's not put a number, a coefficient in front of this uranium, because we want to try to keep the uraniums in check, because every time we put a value there, it's going to change everybody. So let's just get 6 uraniums. Let's put a 4 there, see what that does. So now my uraniums are balanced, my fluorines are balanced, my oxygen I have 2, but I have 4 hydrogens, so if I put a 2 there, that looks good. So there it is. Let's move D down here. Okay, so there is the first question. Honestly, it's not a super super difficult question, but it is one that will cause you to stop and think. And you'll have to really bring out your problem solving skills and think about, what is the information given? You're given a lot of information, and at the time you're like, whoa, how do I process all that? But again, probably not a bad idea, even though it doesn't tell you to write out the balanced equation until the end. I personally would need to do that just so I could see it, and then write the values above so I could see it. Just, this is an organizational step right here. That would never be graded. But again, it would bail you out of a lot of trouble there.